Hello, good morning. Hello, good morning. Good morning.
Good morning, sir.
Yes, this I think we had discussed something about the planning on the very first day, and because of that time constant and the common inaugural ceremony uh, by the AICTE ATAL Academy, so I could not continue with this. Now we have some around 35-40 minutes, so I'd like you to take to the raised part of the presentation, and then after we'll start the next presentation at 11:45 after uh, uh, 15 minutes of the break. So now I'd like to continue up to 11:30. Okay, so is this slide visible to you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, so just to uh, have uh, the discussion what we had before. So we discussed something about this optimal planning of that, and that basically that depends upon the number of aspects. Primarily, we consider that the total net present cost, that is the NPC, and the levelized cost of the energy that depends upon the annualized cost of the system. And because of that, we need to calculate the annualized cost of the system, and which is the components annualized cost minus the miscellaneous cost. So that is basically that the annualized minus some other cost. And mainly what we need to consider is electrical load, thermal load, solar potential, I mean irradiation level, diesel price in the prevailing zone or area, and other system economics. So this part, these components we had discussed, and then we also gone through this. That is a Homer simulation tool developed by the US National Renewable Energy Laboratory, and that is to assist in the planning and design of the renewable energy based microgrid. So this analysis was done by Omar and Kankar Bhattacharya. So what they have done is they have taken different sources and options on the different size and units, life of the different components, and how they have used it. The additionally, for example, when they have used the variable distribution for say for solar, the derating factor they have considered is around 90%. Micro hydro is around scale annual average of 550, 100 and 150 liters per second, and battery which is having a nominal capacity of 225 ampere hour converter. And for the grid, the price of the electricity is being taken as 140 cents per the unit, and the diesel generator, the minimum load ratio is to be 30%. So this analysis was done by some other, and the reference is given below. That is optimal planning and design of the renewable energy based supply system for the microgrids. So that gives some idea about how the microgrid can be planned. This is used for getting the economical results. This may not do with the actual flow of the power. So that gives some financial aspects and indicators. When till now what we have discussed, we have discussed the different aspects of the microgrid, the features, advantages, disadvantages, and the control strategy. But initially when we want to establish a microgrid, then what factors we should look into. So that is also very important. You cannot go for a number of sources. If I want to make the system more environmental friendly, and I want to have the very high percentage or the fraction of the renewable energy penetration into the system, then it's not like that we can go for solar, wind, biogas, and everything whatever is available on the market. Apart from that, we need to look at the different aspects of that, and that needs to be considered in the planning of the microgrid. And one of this, I'm just discussing one of the techniques. This is not the only technique, it is one of the techniques which is known as the MCDM technique. So it stands for the multi-criteria decision making. uh, this is the flow of the what you can say is the planning methodology. So first you need to have the forming of the microgrid, that is our objective. Second is you need to identify the alternatives. The blending of two or more sources can also be possible. Then we have to consider the different criteria: economical, technical, structural, operational, and others. We have to identify, we have to compute the weights, and that is to be given to the MCD process, multi-criteria decision making process, and that gives you the alternative ranking. And based on that alternative ranking, we have to identify whether the objective has been achieved or not, and if it is achieved, then what is the best alternative selected. Okay. So in that case, you may have the priority, you may have the ranking of the system, and if you don't want to go with the first alternative, then what is the next? So that is to be considered. Now we had also gone through this part of this slide. So what we have considered is the economic issue, structural issue, technical issue, operational issue, and other issues that includes the environmental, societal, stakeholders' preferences. And the slides will be shared with you, so you can identify what are the different sub attributes for that particular primary attributes. Okay, so this we had discussed. Apart from that, we had also discussed that the inherent nature of it. What is the inherent nature? I mean, what would be the energy cost? Should it be high or should it be low? So if you look at the energy cost in terms of the dollars per unit, then it has to be low. And in contrast to that, what would be the expected lifetime of the system? Then it should be as high as possible. If you look at the modularity approach, then it should be highly modular in nature. So it should be possible that once you have installed a 20 kilowatt system, then it should be upgraded to 40 kilowatt system, 60 kilowatt system, 100 kilowatt system in upcoming years. So that is also one of the requirements. And then the weights are calculated, weight vectors for the criteria and sub criteria, as you can see over here. In this case, economic, operational, structural, technical, and others criteria as overall primary criteria have been assigned and for the computed weights. So here it is shown that the economic is given the majority of the weight, then comes technical, then comes operational, that comes structural, then comes others, and then at last it comes to the structural. Apart from that, if you look at the sub criteria of economic, structural, technical, operational, and other criteria, then you can see that the initial cost play a very significant role. Then comes energy cost, and then comes internal rate of return and maintenance cost. Similarly, in the structural, lifetime in years, that plays a very crucial role. uh, CO2 emission is again very important. Operational criteria, if you look at that, both these aspects are equally important, that is the efficiency and the energy production from the system. If we look at the technical criteria, then the local technical skill requirement and the generation capacity. It doesn't mean that whatever you have, but it should not have the enough or the sufficient generation capacity. So the generation capacity is very important. Then also we have considered the availability of the fuel. It should not be like that you have a very good system, you have a very good generator, but in that particular region you don't have the easy access, easy availability of the fuel, which is very much compatible for that particular system. So that is these are some of the aspects that are to be looked into. And if we go through the process of the multi-criteria decision making, then the weights of the alternatives are assigned like this. So if we go for the grid and photovoltaic system, here it has been considered that it is not an islanded system, it is a grid interactive system. And with the grid interactive system, we need to analyze. So in the grid and PV is the most beneficial alternative. Then it comes to the grid and PV battery energy and CHPC system, combined heat and power cycle system. Then the others are given the different weightages, and the list beneficial is the grid and PV and battery energy storage system. So that depends upon the different weights to be computed, the different factors which you have considered. What is the objective of the decision maker? What is the objective of the planner? What is the objective of the stakeholders? That plays a very vital role in deciding the priority of the alternatives. Then one more analysis study was done for the rural remote area of the Tanzania. And the microgrid is designed to serve the rural remote region of the Tanzania with an approximate energy demand of 1,000 units per day. So it is a for small residential pocket. The comprehensive comparison has been presented using the Homer and the fuzzy analytic hierarchy process based on the multi-criteria decision making, that is amalgamation of the fuzzy AHP and MCDM. So these techniques are used for the planning of the isolated microgrid system, which is formed by using a group of sources. Now here the group of sources are more, the number of sources are more, that is photovoltaic generator, turbine generator, micro hydro, biogas based generator and battery storage system. So I think almost all possible sources are taken into account, considering their availability and feasibility at that particular remote area which we have considered. So in this study, the 10 various alternatives comprising a blend of aforementioned sources have been considered. And at the end of the analysis, what has been found that $0.0694 per unit was found as the levelized cost of the energy, that is LCOE, for the optimized case when the Homer Pro comprising all four aforesaid components. So all four components are taken into account, and when we take all these components into account, then the energy cost would be this much, that is $0.0694 per unit. And these are the results from that. So in that you can see that the alternatives are how alternatives are ranked for this particular system. For this a given system where you have a biomass based generator, you have a small hydro, you have a wind turbine, you can see that the size of the wind turbine is in, not in terms of the tens of the kilowatt, but is it 5.1 kilowatt. You have the load, and you have a load profile which is around 1,000 units per day is the demand, and approximately it has 150 kilowatts of peak. So you have number of this photovoltaic panels, you have a battery system. So the specifications are given below. The generator, generic biogas generator is having a capacity of the 40 kilowatt, and there is one unit. Then PV system that comprises of 30 kilowatt, and it is of one unit. So the each panel is 325 watts. The storage system is 10 kilowatt and 40 kilowatt hour capacity. The wind turbine is 5.1 kilowatt, and the hydroelectric is the Nuttall free jet type, which is 49 kilowatt of capacity. Okay, so one unit of this Nuttall free jet. Then there are four wind turbines, each is having a capacity of 5.1. So there are four such wind turbines. So in total, it would be around 20. Then we have a storage battery of 10 kilowatt, 40 kilowatt hour each, and there are such five battery stack. And at the end of the analysis, what is being found is the PV and the wind is the most economical solution. Then the second comes PV and hydro. The third comes PV and bio. The fourth comes PV, wind, and hydro. And the last combination is A10, which is PV, wind, hydro, biomass, and ESS. So what is inferred from this? It has been inferred from this that it doesn't mean that if you employ all the sources, that would be the most beneficial, most preferred combination. Here the most preferred is either one may go for PV and wind, one may go for PV and hydro, one may go for PV and bio, and then PV, wind and hydro. So it may not be possible. Fine. So this is something about, and this particular analysis was carried out for the place which is in Tanzania. It is a sub-Saharan country, and the that place is known as Arusha. So now let's come to some of the features of the Homer energy. So even independently you can design such system, you can, but you must have some details with you. I'll take you to the details what is to be supplied to that particular software. So Homer is basically a hybrid optimization for multiple energy resources, and it is one of the most acceptable and widely used tools across the globe. It requires a project inputs, uh, economics, load profile, site specific renewable sources, and the system components. So it is not possible that it is a generic system and you can have the same result irrespective of the site, irrespective of the load profile, and irrespective of the economics being supplied. So whatever is the input, like any application software, whatever, how uh, carefully you supply the input to the system, the better and the accurate would be the result. Analysis is being carried out in three ways. One is the simulation that runs each system for 1 year for every hour, optimization and sensitivity analysis. We'll again look into this in a little more detail. And the results, what are the results that is generated by the Homer software is economics and engineering, system sizing, performance details, financial, and the different reports. Even you can generate the report that may be treated as a feasibility report for some particular area and for a given size, setup, etc. How it works that we have just explained. So how much simulates the operation of a system by making every energy balance calculation in each time step interval of the year, and for each time step the Homer compares the electrical and thermal demand in that time step so that the energy of the system can be supplied in that time step. Second is the Homer performs this energy balance calculation for each system configuration that you want to consider. So if I want to take like we had just seen that if there are three sources, so it will take one source at a time. So source 1, source 2, and source 3. Then we'll take source 1 and 2 together, source 2 and 2, 3 together, source 1 and 3 together, and then at last it will consider all three sources. So as many combinations are possible, the Homer will simulate all those possible solutions. And apart from that, even you can go for the sensitivity analysis. So some of you might be familiar with the sensitivity analysis. In that, for a given system or given source, you might be thinking of what could be the size of it. It means that if you want to have the 50 kilowatt of the PV system and 50 kilowatt of the turbine, then not only that 50 kilowatt of the PV and 50 kilowatt of the turbine you will be specifying, but instead what you can do is you can go for, if the size of the PV can be 10 kilowatt, 20 kilowatt, 30 kilowatt, 40 kilowatt, and 50 kilowatt. And similarly for the wind, if the wind system you are looking for is of 10 kilowatt, then you can go for 10 kilowatt wind turbine, 20 kilowatt wind turbine, 30, 40, and 50, and so on. So that is also can be done. Optimization has two optimization algorithms. One is the original grid search algorithm that simulates for all feasible system configuration defined by the search space. So as I have mentioned that 10, 20, 30, 40 is known as the search space. So that you need to specify, system will automatically identify and gives you the results. And the third, which is sensitivity analysis. So if there would be a deviation from the given parameter, say if for the diesel, and the diesel price varies, fluctuates on a daily basis, so that can also be done on that. Wind is also changing, irradiation is also changing. So if there will be a change in plus or minus 5% or the 10%, so that comes under the sensitivity analysis. Okay, so just I've just taken the snaps from the Homer site itself. So it is simulation, then sensitivity analysis. Here you can see how it looks like. Then I'll again take you to this part. So at its core, this Homer is a simulation model, will attempt to simulate a viable system for all possible combinations of equipment that you wish to consider. Sensitivity analysis is because one cannot control all the aspects of the system and cannot know the importance of a particular variable option without running hundreds or thousands of the simulation and comparing the results. So instead of doing yourself, instead of doing manually, the system automatically, the software automatically takes care of this system. in the sensitivity analysis. Will give you the optimized result. uh, it examines all the possible combinations of the system types in a single run and then sorts the system according to the optimization variables of the choice. So as you start uh, uh, executing, running the system, the Homer will show this kind of the analysis page. So it has been uh, the the global workhorse for the quickly finding the economical and viable options for the microgrid, especially for the microgrid and distributed generation system. It is not designed for a very large power system. It is a well tested, robust, modified grid algorithm that is being used by it. Apart from that, Homer consider requires a program to chronologically simulate an electrical system for an entire year, and not for a day, not for a month, not for a week, but it gives you the result over a period of year. And even it is possible to go for the multiple year options. The modified grid search approach requires a user to specify all possible options for the searching, whereas the Homer optimizer does not. So there are two options. You can even specify the search space. You can even uh, let the Homer select the possible search spaces. Okay, so what are the inputs that one has to supply? What what are the inputs that the Homer seeks? One is the project information and setup. So locate the project on the map, whether where this site is located at. Second, view the system schematic, whether it has AC or DC bus. Then you can take the components from the model to the library also. Then there are the linked sensitivities. It means that if something is changing with something else, so if you want that, if the load changes, then your the battery storage should start discharging, or I want to connect the load and the battery. So in that case we can say that it is a linked sensitivity. So what would happen if the load changes to the battery? If the diesel price increases, then what should I do with the PV and wind and the storage? So that is the link sensitivity. Even you can enter the different currency and the number format. Paid license users can disable ads, prepare scenario, hybrid power system design, wizard, etc. What are the components basically available? I'm not going in through all the components, but this is just to add the flavor to the presentation. So it is a microgrid controller, use commercial controller developed with C++, and generator dispatch. The load following dispatch generators include the auto sizing, capital and replacement cost, operation and maintenance cost, maintenance scheduling. uh, just uh, yes, okay. So that everything, almost all essential things will be there. So that makes the model more accurate. Lifetime can be supplied. Fuel curve, even if you know the fuel curve of a system diesel engine, if you want to modify it according to the manufacturer, that can also be supplied. Then the solar PV array, again the capital replacement cost and everything, life cycle and everything, components in batteries, the improved battery model builder. Then what type of batteries you are using, it is a zinc, vanadium, capital cost of the battery, initial state of charge you can supply, what is would be the minimum state of the charge, what is the lifetime throughput. If you know this battery will be able to supply this much amount of the units throughout its lifetime, then that can also be given. Similarly for the flywheel, AC DC converter, etc. Apart from that, you can give the derating factor of them, temperature effects for wind turbine. You can specify the improved wind turbine model builder using the capital and replacement cost, lifetime, hub height even you can change. So that has very significant impact on the generation of the power for the different hub heights. uh, Grid power price, what is the sellback price, whether you are feeding power into the grid, whether you are getting some rebate, some revenue from the grid when you are supplying power to the grid, net metering is possible, etc. And there are different kinds of the load. The different kinds of the loads can also be incorporated. Deferable, whether it is a deferable load, non-deferable load, and what is the minimum load ratio, whether the system has thermal load or not. See, if the system is designed for the countries where the thermal load is required, then we need to take into account this thermal load and their effect. Then if you look at the resources, as we had already discussed, you can incorporate solar photovoltaic, wind, hydrogen, hydropower, biogas. So relevant details need to be supplied to the software, like solar irradiation, direct irradiation, global irradiation. Then for if it is a wind, then and this is particularly for the solar case, what would be the temperature. If you go for the biomass, then what is the average price, what is the carbon content in the biomass, what is the gasification ratio, what is the CV or the calorific value or the heating value. And these are some the results that would be generated by the homar. So the sensitivity table, optimization table, filter, you can filter the result, you can get the cost summary.
Shabbir sir,
Ah,
your presentation is not visible.
oh, sorry.
प्रेजेंटेशन में देखा तो शेयर
हाँ, एक just a minute. Is it visible?
Yes sir, now it is visible.
Okay, so I just go back a couple of slides. So I guess it started disappearing from this point, I guess. So these are some of the components and what are the inputs, what are the parameters that can be supplied into that particular software. So as far as the components are concerned, the batteries, types of the batteries, initial and the final storage, what is the lifetime throughput, if it is a flywheel, then what is the capital and replacement cost, lifetime. If it is an AC/DC converter, again the lifetime efficiency. If it is a grid, then even you can supply it, what is the tariff structure. Is there any interruption, the frequency of the interruption and how long the interruption lasts typically for the given interruption case. Then the derating factor, temperature effects, tracking, slope, azimuth. For wind turbine, it is hub height that we had discussed. For the grid, it is whether it is a net metering is possible, is that utility giving back something in terms of the supplying power into the grid. There are the different kinds of the loads: thermal load, electrical load, deferable load, If we consider the sources, then as we had already talked about, the different sources can be employed in it, and the associated details need to be supplied, like the irradiation level, the temperature, if we in case of the wind, what is the wind speed, minimum wind speed, maximum wind speed. uh, if it is a diesel generator, then what is the fuel curve, what is the efficiency, uh, etc. And at the end of that, the different kinds of the results can be generated, like in terms of the sensitivity table, optimization table, uh, cost summary, comparative economics of the IRR and ROI, that is the internal rate of return and return on investment. So basically it gives the different kinds of the views of the cash flow. It also gives the emission level, what would be the emission for this particular combination or this given system. Optimal system type plot, surface plot, line plot, spider plot, optimization plot, almost all every kind of the plot that gives the concise idea that can be available. Report can also be readily generated. uh, Economics sensitivity variables are the annual nominal interest rate, expected inflation rate, project lifetime, fixed capital cost, fixed operation and maintenance cost, capacity shortage penalty. If we are designing a system which may likely come across the capacity shortage, then what would be the penalty that one has to pay, that also can be supplied. In terms of the emissions, this will give you this set of the emissions: carbon dioxide, monoxide, unburned hydrocarbons, PM, sulfur dioxide, nitrogen oxide, etc. And what are the constraints that can be considered? The maximum annual capacity shortage in terms of the percentage, minimum renewable fraction. So if you are going to design, is if your objective is to have the 25% of the renewable fraction into that existing microgrid, then that can also be restricted to 25%. Operating reserves, that is a percentage of the current load, peak load for the solar and wind, etc. So these are the some uh, uh, parameters that without which your system cannot be so effective and so accurate. So it is not like you can directly jump into the Homer application software and then you start putting all the sources without knowing the significance of each of the parameters which are very closely governing the performance of that particular source. And if you do so, then your result would completely be deviating from the very true result. So this, I'll just go through the some of the snaps which we had discussed in past slides. So this is the system. What is to be done in that case? These are the sum of the sources. Those are taken into account. The same I have considered, and this is a location selected where one would like to install or establish the microgrid at. So discount rate considered is 8%, inflation is 2%, capacity is neglected, and the project lifetime is 25 years. So this is one of the pages of that. In that, you have to specify the load and you have to supply some of the basic informations. Then that comes to the second part, which is a generator. I'm not going again into the details of that, why the values are selected. So in that, minimum load ratio is 50%. Heat recovery is not being considered. The lifetime of this particular generator is 20,000 hours. Minimum run time is 15 minutes. So the generator has to run at least for 15 minutes once it has started. What is the capacity? Say 15 kilowatt. What is the capital cost? Capital cost. What is its replacement cost? What would be its operation and maintenance cost? And for the capacity optimization in the surge space, this 40, 45, and this 50. These three are considered. Apart from that, the lower heating value is 18. The density of the fuel is 1.15 kg per meter cube. Carbon content it has is 5%. It has no sulfur content. So this is for a generic kind of the genset. Then say for example, this is for the hydro. So the capital cost is around this much, $250,000. Replacement is around $125,000. Operation maintenance lifetime, it is connected to the AC bus. Being the hydro, the pipe head loss is considered to be around 15%. what is the available height. It is a micro hydel, so available head is 7 meters. The flow rate is say around 1200 liters per second. The minimum flow rate to be considered is around 21, maximum is 105, and efficiency of this is around 59.52. So you have to refer the particular manufacturer's data sheet to fetch those details. Then say for example everybody is interested in a wind turbine, so I've taken this 5.1 AWS SC 5.1 wind turbine. The capital cost, replacement cost, operation maintenance cost, I've used the search spaces 4, 6 and 8 of capacity, and the wind speed is also given. Say for example here, if the wind speed is 2.2 meter per second, then the power output would be this much. If it is 4 meter per second, the power output would be this much, and the curve of the power output versus the wind speed. Hub height is considered as 12 meters, and the lifetime of this wind turbine is 20 years. Then electrical load, which is very important, so because the result would result would change its path from uh, the intended to the other if it is supplied by the random kind of the profile of the load. So here the load profile is this two humps kind of the load profile we have considered, and in that the average load is scale 850 units per day, and the average is 35 kilowatt, peak is around 125 kilowatt, and load factor is considered is around 0.28. uh, Random variability per on the daily basis is around 10%, so it means that the daily the load variation would be plus or minus 10%, and the time step is around 20%. Lifetime of this is 25 years, and scale annual average is 850 units per day. So this is a very important part of the simulation or any of the design for the microgrid. The converter is bit simple to have the details. I mean, the capacity, capital cost, replacement cost, the lifetime is 15 years, efficiency is as high as 95%, 96, 97%, relative capacity is 100%, efficiency of the rectifier and inverter are given separately as 25%, oh sorry, 95%. Then comes to the PV. So here the 40 kilowatt capacity is considered. Capital cost, replacement cost, operation maintenance, search is 30, 40 and 50. So the system has to execute for 30 kilowatt capacity, 40 kilowatt capacity and 50 kilowatt capacity. And the derating factor for this particular model and for this manufacturer is found to be around 88%. So that is being given. And this is search space for MPPT. uh, Lifetime of this particular MPPT controller is 15 years, and the search space is 20 and 30. The efficiency of this MPPT controller is 95% being considered. The storage is this is a storage which is a 48 volt battery. Nominal capacity is 833. Round trip efficiency considered is 64. Maximum charge current is 200. Maximum discharge current is 313. Lifetime of the battery is obviously be less than the other electromechanical systems, so it may be even 10 years. Now the batteries are coming which is giving almost 15 to 16 years of the warranty. Throughput is this much. The search space considered is 3, 4 and 5. There is one string of 48 volt. Initial charge state of charge is 90%, and minimum allowable state of charge considered is 20%. So this is something about the Homer. Now I guess with this information, at least a primitive kind of a model can be developed. And if you have any question, you can raise your question. It is because of constant of time, I need to rush through all the slides, and it may be possible that I may not be able to explain more detail about this slide. But as we thought that we need to share this thing with you. So without such software or application software in which one can design and one can feel the uh, design of a microgrid is I think yes, this software is, it's not free, but you can all download an evaluation version, and that you can use it for 21 days. You can download it from Homer's site itself, and there are two variants, Homer Pro and Homer Grid. So what we have just discussed is a Homer Pro, and the free version is available, and that you can play with that for 21 days, and it is a full featured version. Yes, sir. If there won't be any question, then uh, we can close this session. You can always send your queries later, and it is almost 11:33. So thank you very much for listening, patiently listening this session, and we'll start the next session at 11:45. 11:45 by Dr. Nida Jafri. She's from Empowerment, Malaysia, and she would further be talking about some case studies of the planning of the microgrid. So I request all the participants to be on time, and we'll see you at 11:45. So there is a 10 to 12 minutes break. Thank you.